Hello, this section is about the trigonometric functions, and we will try to solve a couple of applications problem. Okay, let's start with this one. A particular person, let me check, yes. A particular person's height oscillates throughout the day with a period of 24 hours. The average height is 170 centimeters, and the maximum height is 173 centimeters. At 4 a.m., the height is 170, and that means the average. And it is increasing. Find the possible formula for h of t, the height in centimeters, t hours after midnight. Find the time when the height equals to 169 centimeters. Okay, and we will assume, since it's a periodic scenario, every 24 hours, everything repeats, we will grab sine function. Sine or cosine, we can always debate. However, it's telling us that is from the average, from the midline, is increasing. I mean, we know how nicely the sine function behaves. I mean, let's look at the graph first of all. I can try actually, because we may try to put our graph at the same place. Okay, time and height with respect to time. And I can start just drawing a sine function. You can see increasing and a little bit maybe. No, it's okay. It's okay. Let me, of course, I knew it. Let's try to put back. Okay, time. I mean, what we have, we're starting from 0. That's how sine function behaves. We're starting from the midline. We're going through the midline again, and we end. And the period is, we know that is 2 pi. Right, 2 pi. Okay, let me just say for the normal regular sine function, 2 pi. Then I just want to point the symmetry. This the middle point is exactly in the middle. It will be half of 2 pi, and also the maximum value is happening at halfway between 0 and pi over 2, and this will be, that point will be 3 pi over 2, which is minimum. Okay, but what I can do, since I want to put everything on this graph, I will change a little bit our period, because our period is 24 hours. That means let me remove this and let's put respectively the same values, but with respect to the 24 hours. Oh, if this is 24 hours, the behavior of the height will halfway, we will have 12 hours, yeah? And then the maximum, yes, the maximum height will happen in the middle, which is 6 hours, and this will be 12 plus 6, 18, the minimum, okay? So we can see now we have, it's so important to use that scale, 6, 12, 18, 24. Okay, but of course, this is not our scenario, because the height is not the average, the midline is not 0. I mean, the midline in this case is 0, and of course, we do have 1 and -1 as a minimum maximum. But let's make the shift. We can see that the average height is 170. I mean, 170 will be the midline, 170 centimeters. We will shift that graph 170 units up. Yeah? That x-axis will be shifted. And now we also have the information that that average height, 170 centimeters, is happening actually at 4 a.m. Then 4 a.m. is telling us that we will shift 4 units, 4 hours to the right. Okay, let's try to do it. I will pretend that this, I will go, let me just show you, 170 and 4. I mean, let's have the good 170 maybe here and 4. I mean, this point, the 0, 0, it's moved here. Right? This will be 170, and that's the midline. Okay. And it's moved here. That means this is 4 hours, 4 a.m. Now the maximum, now I can start drawing symmetrically. I can start drawing symmetrically the sine curve, but we have to be careful for the labels. Because everything must be, each dot must be shifted. Each blue dot represents the new point for the corresponding yellow dot. Okay, but let's see if I will manage to do slightly slow. No. That has to be shifted. No, not good. 4 units. Okay, and then, okay. Let's see. It's supposed to be nice and symmetric, I believe. Okay, I believe it is. Let's make labels. The maximum height is 173. I mean, we can put it. Oh, please do not. Yes, I managed to keep the y-axis. H of t. It means maximum is 173. Okay, now this is from 0 to 4. From the maximum was happening like for our templates, I can say this way, at 6 a.m. But now we're shifting everything 4. That means this will be 10. Okay, makes sense. Now that was the 0, the midline was at 12. Now we'll be at 16, which is actually 4 p.m. Okay, now the minimum was at 18. We're adding 4. Oh, okay, 22 and 24 hours. We're shifting 4 hours plus 4, 28. Okay, the blue curve, which of course it's a one single curve. I was just trying to make it. Yeah, it's our curve. It's our function. Perfect. We may find a minimum. Yeah, of course, we will ignore this. So nice graph. We will find a minimum, and you can probably tell me the minimum because it's the same distance from the midline like reaching the maximum. We may see the amplitude. The amplitude is 3 centimeters. I can make it. Yeah? A is 3. A is 3. I mean, this will be 167. Let's use blue. 167. That's the minimum centimeters. Okay, now we need a formula. The formula for height with respect to time, the general formula is A, amplitude, sine, and then quantity B, which depends on the period, we will calculate it, and then minus the quantity C, which is a vertical shift. We know what we did, how many hours we went to the right, and plus D, the horizontal, oh, no, that's horizontal shift. I meant horizontal, and this is a vertical shift. Up and down, 170. Okay, that means let's actually fill out our values. The amplitude is 3. Sine, and then we moved 4. Yeah, this will be 4. We will compute B in a minute. We do have, yeah, we have 3, we have 4, and then we moved 170. Yeah, the 0, the point 0, the yellow dot 0 was moved 170, and of course 4. Okay, that's our model. With what we now we're missing B. It's mean quantity B. We can calculate, okay? We can calculate because what we did, we have to take the regular period of the sine function, sine model, 2 pi. Yeah, everything repeats 2 pi, but we will divide that 2 pi by 24. This means the quantity B is pi over 12. Pi over 12. And we will see, thinking about 2 pi as a regular like cycle, but we divided by 24. That's means 24 was our period. Okay, period was 24. Okay, so we do have part A. This is the model. That's the sinusoidal model. Really good. We see the amplitude, we see the horizontal shift. Always is minus, then we go to the right. When it's addition, we will go to the left. And this addition to the entire value, meaning that we're shifting everything up 170. Okay, now what we have to do? We have to find out the time on the number on the x-axis when the height equals 169. Well, let's see. 169 is somewhere here. I will draw the line. That's the moment. And that's the moment. Oh, well, we're looking for these times. Okay, I don't know if my points on the, that's we have to find the green dot. We may estimate, yeah, it will happen between 16 hours after midnight, which is 4 p.m., between 4 p.m. and 6 p.m. That's because that's quite accurate graph. Or the other time that will correspond to the 169 centimeters, it's happening after midnight, yeah, after midnight, but before 4 a.m. because 28 represents again 4 a.m. Yeah, a cycle of 24. Okay, but let's find the values of t for that green dots. We will need t sub 1 and we will need t sub 2. But let me nicely squeeze it t sub 2 because that 24 was just a tool, t sub 2. We have to set up the blue curve, which is the blue equation, equals to 169. Let's see if we can solve this equation. Not quadratic, trigonometric equation. Okay, I will go to the next, the next slide. I can use the green. Okay, the amplitude free sine pi over 12, t minus 4, plus 170 equals to 169. That's the trigonometric equation. Let's isolate trigonometric function sine on one side. I will subtract 170 from both sides and divided by 3. Sine of pi over 12, t minus 4, it will be 169 minus 170, it's -1 divided by that coefficient 3. Okay. Means sine is negative, and let's come back. You can see definitely it's a good, because that part represents, for the yellow, we can see that's the negative part. Okay, with respect to the solution. But 1/3, unfortunately, is not the value from the unit circle. Well, we have to use the inverse, okay? That means we definitely know that function sine is negative in the 3rd quadrant and in the 4th quadrant. Okay, that means I will use this. We will have 2 solutions, and it's right. We need t sub 1, t sub 2. Okay, that means how can I write? Let's say the 3rd quadrant. We can say that the angle, okay, the angle which is everything here, that's theta, theoretically. Okay, that means that theta pi over 12 t minus 4 equals to just sine inverse of negative 1/3. Or that theta pi over 12 t minus 4 equals to, because if this is the angle, like I can draw it, the third quadrant, the third quadrant will give us that angle. But the fourth quadrant, we will say pi minus inverse sine of. And since this is, let's actually, wait a minute. If this is negative, okay, because this we will go the counterclockwise. This will be fourth quadrant, negative fourth quadrant. But the third quadrant will be pi, because that's pi, and minus a negative value we will add. That means we will actually reach the third quadrant. Okay. However, in general, we always saying pi minus the value. If this is positive, it will give us the second quadrant and the first one, if it's positive. If it's negative, we will have fourth quadrant and the third quadrant. Okay, good. Now let's solve it. We will multiply both sides, sine inverse of 1/3. We will multiply by 12 over pi. And now we will add 4. Okay, that means we will add 4. Sine inverse of 1/3 times 12 over pi and plus 4. Okay, that means this is the solution. And of course, this solution repeats every 24 hours. If we, too fast. This repeats every 24 hours. That means I can, and this will be also correct. 24 hours. Okay, but when we will use the calculator, that value, because what's happened, we may look at this. What I was going to. Okay, when we will use calculator, I think I have to add 24 hours because the value will be in before I use the calculator, and you can also try, we will get 26.7. If you use exactly this, including 24. And 26.7 means 26 hours, almost 27, 26.7 hours after like midnight. That's when we're reaching another midnight, 24, and then we have 2 hours left. Yes, like 2 hours, 0.7. I mean, this is actually, that will be that time. Yeah, this one will be our T sub 2, 26.7, and makes sense, is between 24 and 28. And when we would like to find the time, we can say like, because it's 2.7, 2 a.m. and 0.7 of an hour will be like 42 minutes. Okay, that means you can see I added 24. Okay? That means this one is actually, let's say, T sub 2. Okay, that means T sub 2, just to be, it's approximately, it's happening that height, it's happening at, again, at 2 and 42. I just calculated 0.7 of 60 minutes. Okay. Okay. Now let's see what we will get on this side. The same thing. I will multiply both sides by 12 over pi, which is this side. I still don't know. I will just use calculator at the end. And I will add 4. That means now we do have 12 over pi times pi minus inverse sine of negative 1/3 and plus 4. And I think this one Depends, you can add 24, or if we okay, we don't have to add. This will be, and when I used calculator, I just realized that this quantity is 17.3, and I hope you will get 17.3. And now let's come back to the graph and make sense. Make sense. This is 17.3 hours after midnight. And it will be like 16 is 4 p.m., 17 will be 5 p.m., and 0.3 is like around 20 minutes. Okay, 5 p.m. and 20 minutes. Makes sense, makes sense. But just not to be confused that I did add 24 hours to this one, because if, let me come back, if I will calculate just this quantity, what I will probably get 2.7. Yeah, and 2.7 makes sense because it's before 2, yeah, it will be, it's not a minimum. I mean, it will be, yeah, it's also another green, yeah. It will be 2.7, and makes sense also because 2.7, the difference in time between 4 and 2.7 is 1.3. 1.3, and that's because we can see the same difference. 16 plus 1.3 is 17.3, because everything is symmetric. Everything is symmetric. Yeah? So just that box will give us 2.7, but adding 24 is 26.7. Okay, we did solve it. Let me just confirm the time, actually 5 p.m., 5:20 p.m. Perfect. Yeah, that's mean this is p.m. and this is another, we have to pass the midnight end. Yeah. You may pause the video, you may look at the graph again, and just make sure that we can get the answer correctly. Okay, let's solve one more. Okay, similar thing. That's the solution, that's a continuation. Oh, that was from the class. And now let's look at this question. What we have? Similar struggle. Let's see. During the winter, a smart thermostat is set to adjust a temperature on the 24-hour cycle. Again, period is 24. It is programmed to reach a maximum at 69 Fahrenheit at 9 p.m. Oh, big shift. And minimum 61 at 9 a.m. Okay, 9 a.m. Let T of t be the thermostat settings T hours after midnight. Again, midnight will be 0 for us. And we have to still shift it. And the same thing, find the possible formula for the temperature, which depends on time. And what is the time throughout the day? Throughout the day is the thermostat set to 66 Fahrenheit. Okay, and actually this one, since we don't really have information if it's increasing, decreasing after the average, we may use sine or cosine. But I will just make it easier and I will choose sine again. Yeah, then we will just repeat what we did almost. Okay, so what we have to be really careful. We know now, we don't know the average. We know the maximum 69 and minimum 61. And the midline is in the middle between maximum and a minimum value. So what I can do, I have to be really careful. Let me draw it because we need okay, if 69 and 61, it's 8, the difference is 8, right? The difference is between maximum and minimum is 8 degrees Fahrenheit, then halfway will be 4. The amplitude is 4. I mean, amplitude is basically 69 minus 61, yeah, and divided by 2. It is 4. Shall I draw? We know how to. Okay, let me draw differently. I will draw. That means 4. Okay, 4 is the amplitude. However, going from the minimum 61 up to 4 Fahrenheit, yeah, 4 Fahrenheit, we will have 65 the midline. I mean, let's do the midline 65, but we will still try to shift it. Okay, I can start with this, okay? This is 65. Let's do this way. Yeah, we know the sign. Now, okay, maximum value is at 69, perfect, and minimum value is at 61. Amplitude is 4. Okay, we will put to the formula in a minute. Now, since we have 24-hour cycle, okay, we can see 24 hours. That's 24, that's halfway, 12. This is happening at 6. This is happening at the moment. That's our template. At 18. Okay, 6, 12, 18, 24, 0. But I've already shifted to the midline, and yeah, that's me. I didn't draw just the sign. Okay, now what we will do? We have to figure out where it is programmed to reach maximum at 69. It's happening at 9 p.m. Oh, okay, 9 p.m. How many hours is 9 p.m. after midnight? Yeah, I think it's 18. And minimum is at 9 a.m. 9 a.m. That means it will be, okay, let me start. I can maybe use the blue color. We will have a little bit longer. Okay, that 18 hours after midnight. That means my graph has to have maximum. That means that maximum we have to shift here. Okay, and it's actually good because then I can, am I right? 9, oh, no. 18 is 6 p.m. 9 p.m. is 21. Oh, even further. That's mean, no, that blue dot's supposed to be at 21. Of course, it's, yeah, 21. So we will actually go up to 21. 21 represents 9 p.m. Am I right? Yes, and that has to be maximum. Okay, then I have to draw my sine function, and I can just draw, and we will try to make labels correctly. Oh, a little bit too, maybe too small, because I need to go there, midline, and okay, let's say there. That's the graph, but let's see if everything matches, because I can also draw the graph a little bit on this side. Okay, 9 a.m. is 9 hours after midnight. That means the minimum, minimum supposed to be somewhere here. I mean, we actually, let's see what we're shifting. Yes, what we're shifting, because now what I did that shift. Okay, I did that shift, which is 20. It's actually, yeah, actually we can figure out it's not exactly 21, but it's 21, but I started from 6. I mean, this will be our vertical, which I think was not vertical, horizontal. That was the C quantity in our formula. It will be 13. Am I right? Oh, no, what I'm saying, 15. 15, because it's the difference between 6 and 21. 6 and 21. Okay, that means if we're shifting 15, that will be 15. Makes sense because this one and this one. And then, yeah, because I don't have that part, but we know that the minimum, let me do this way. It's happening at 9. Because 9 a.m. Okay, but we don't, yeah, let's, yeah, because we do have kind of like different values given. But when we add 24 hours later, 9, this is supposed to be 33, because, am I right? 24, yeah, just the whole period, 24 hours after 9 a.m. Okay, I believe that's the good graph. Yeah, we can still make it. Yeah, each part, each quarter of the graph represents 6 hours because nothing changed. The curve that didn't change. And we can see 15, 21, correct? 21 plus 6 will be 27. Okay, and then plus another 6, 33, and another 6, 39. Yeah, of course, it's a cycle of 24. We know the times. And this represents 9 a.m. Yeah, I think we have the graph, but we don't have the formula. Let's find out the formula. T, which depends on T, we decided to use sine model, quantity B, we will compute this, T minus C, horizontal shift, and plus D, vertical shift. And the final answer for part A is amplitude is 4, sine, and quantity B is still the same like the previous question. Original 2 pi, always divide by the period given, 24, which will give us pi over 12. We shift 15. Yes, I hope we are okay with that quantity. It's just the distance between 6 because we were moving the maximum value. We didn't move the 0, the midline. We're moving the maximum value, and maximum value was happening after 6, a quarter of the period. And then we moved 15 to reach 21 because that was given. 21, this is 21 hours after midnight. And then we shift everything to the midline, 65. Okay, that's the model. Perfect. And now let's take a green pen. We have to find out what time, which actually this is time, we have to have a labels. And that's the temperature with respect to time. We have to find what is the time for 66 Fahrenheit. 66 Fahrenheit, I can draw the line. And we're looking for that time and that time. And you can estimate between 15, like 3 p.m. and 6 p.m. And this one is actually right after midnight. Right after midnight. Everything is symmetric. That amount of time after 15, after 3 p.m., it will be exactly the same like that amount of time before 27, and 27 represents what 27 represents 3 p.m. a.m. 3 a.m. 3 a.m. Yeah, the same distance. Okay, let's solve the equation. Again, the same thing that we did. Let's try 66. What I will do, I will set up the equation here. Our temperature must be 66. 4 was the amplitude, sine pi over 12, t minus 15, and plus 65 must be equal to 66. Okay, let me just rewrite this. 66, and that was the equation. That's how you will set up. Now let's isolate just sine function, t minus 15. We will subtract 65, which is 1, and divide by 4. That 4, 1/4. Again, it's not the value from the unit circle. I would like to see 1/2, or maybe square root of 3 over 2, or maybe square root of 2 over 2. Well, it's okay. Okay, But now it's positive. Now it's positive. Then we know that sine function is positive in the first quadrant and the second quadrant. I mean, we will need the solution. Okay, let me, because the period, but we will need the solution from the first quadrant and we will need from the second quadrant. Okay, so now the angle, the theta, which is everything inside here, that's theta. Theta equals to, this is theta, pi over 12, t minus 15 equals to basically inverse sine of 1/4. Okay? Now the second option is theta, which is pi over 12, t minus 15 equals to, we remember, pi minus, we can see pi minus inverse sine of 1/4. Okay, which actually I can use also arc, yes, arc sine values. However, we're supposed to also say plus 2n pi. Like plus 24 hours, 2n pi, because everything repeats. If we would like to include the entire solution for infinitely many solutions, because this repeats. Okay, so now let's solve it for t. We will multiply by 12 over pi, sine inverse. Okay, let me just get this one. We will add 1/4 and add 15. Am I right? Am I right? I mean, we still need this. I'm just thinking, okay. I mean, it's fine because 24 hours we can always add. We will check what is this value. Okay, I mean, this is the first. Now, the same thing. I will multiply both sides by 12 over pi, pi minus inverse sine of 1/4, and add 15. Okay. Cool. Now, when I used calculator, this value, you can also try. This value is 15. You have to use the radians, of course. 15.965. It means 15 hours, yes, 15 hours after midnight. We will figure out which one is T sub 1, T sub 2. This one, when you use the calculator, is actually 26 point, I'm so accurate. And let's see what it is. This one will be like around 15 is 15. When we use the military time, it's 3 p.m. and it's almost 4. 3:58 p.m. And it makes sense. Let's see. 3. Yes, it's right after. Oh, no. It's almost 4. Almost 4 p.m. I mean, this one is T sub 1. 3:58 p.m. Makes sense. Makes sense after 15. I mean, this is this one, and I can name it 1. And T sub 2. When I use calculator, I've got, 26.035, but 26 is 24 is a midnight, 2 hours after, and almost 2 hours and a couple of minutes, 2 minutes, a.m. Starting a new cycle. Let's check. And yes, it's after, it's after midnight. Yes, that means this one is T sub 2, almost 2. a.m. 2 minutes, 2, okay. We do have a time, almost 4 p.m., almost, a little bit past 2 a.m. when the temperature is 66 Fahrenheit. Okay, that's you can see it is fun. We need time, we need patience to solve all of these problems. Okay, and we have another one, but I would like to leave it for you. Everything is given. Everything is given. The only thing that for this question, okay, I will suggest that the number of days, because we're looking at the yearly cycle, in order to avoid like fractions, I will use, instead of 365, maybe 364. Okay, that means I will use that as a period, or even 360. 360 will give us such a good division, but 364 is also good. Yeah? I mean, we will say that the yearly, I know that is 365 or even 366, but you can try to use 364 as a whole cycle period. And then you can try to follow exactly the same steps that I did. Okay, enjoy your trigonometry. Thank you.